have been working on their distribution, fleet size mix and route planning for 20, 30 years. And they basically said, at least in New South Wales, they were confident they had it as good as it could be. So they gave us access to data and a challenge. Can you do better? And what we're able to do is to reduce their cost of distribution by 10%. That was early days. What we've done since is really flip the model around to gross profit after distribution. So thinking about individual customers and what is the cost to deliver or the profitability to deliver to a customer. And when you've got 24,000 drop points around the nation, that's a fairly important metric that they hadn't done. When you've got Coles and Woolies introducing $1 a loaf bread, and it costs $1.15 to bake and package a loaf of bread, and distribution is 30%. On top of that, anything you can do is important. When they did the first analysis, and you would have exactly the same in Coke if you did your profitability by drop point. As you're looking at a chart, if you've got your cumulative profitability and your number of customers on this axis, you're going to have a curve that goes like this. So you'll have something like, 70, 80% of your customers that contribute 120% of your profit, and you'll have a tail of customers that kill profits. You lose money. So we were able to recreate new routes, different fleet selection, and in some cases, changing the source from which distribution centre to which drop point, different mix than they had thought about. We were able to change for them what was a 70-30 to a 90-10, but then more importantly, or as importantly, for the 10% of customers that were still unprofitable, give their sales reps the exact information they needed to be able to sit down with the customer and say, if you change your SKU mix into a high margin mix, if we can reduce our drop frequency from 7 days a week to 3 days a week, or in some cases, if you can come and pick up 5-10 kilometres, will deliver to a nearby town, and you just do the last bit, and then we can make it work. So suddenly they can have a meaningful customer by customer conversation.
Very interesting.
Do you want to play the game?
I just thought we could quickly show, let's see if this works. This is the cost to serve thing. So this is the revenue from different customers, and I think the distribution point is here. So it's just not a multiple distribution scenario. And then this is their existing routes, and this is, you can see the red guys are the guys who are not profitable. So a mix of profitable and unprofitable people with their existing setup.
Size of the dot, is that volume?
That
volume.
size of dot, yeah, volume. And then you optimise that. So you've cleaned up the routes. Most of the people have gone green, except for this unlucky guy here who was just not totally non-profitable. So you can choose to drop him if they have it, as they have in this scenario. Of course, you could wear the cost or
Just say, okay, we want to make sure we have that spread. So.
Or pull him into a different DC run.
Yeah.
But that's in a nutshell the cost to serve aspects. So we can combine the optimisation with the cost to serve aspects. This game here is just about optimisation, and it's a nice game where you have to decide what fleet you're going to purchase to do these deliveries. So here's a set bunch of deliveries. So these could be Coke deliveries, number of pallets to different locations. And you've got options of setting up fleets in Sydney, Newcastle and Canberra. Yeah. It's part of the game. It's not no particular example, it's just an example that captures the concepts. And you get to buy your trucks and allocate them for different locations. They have different cost models, different capacities. And in fact, one of the strengths of NICTA's approaches to optimisation, which is absolutely world-class, we've cornered the market on some of the world's best, is called constraints programming, where you can put in lots and lots of rules, lots of detailed rules about which trucks can go where, when drivers can drive, time windows. There are almost no restrictions on rules you can apply. So you choose your fleet, and I'll just tweak the fleet around a bit. That's one solution. We leave it as a game to work out what the best fleet is. Of course, we could get the computer to work out the best fleet for you. But here's one solution. It's about 3%, 4% over the best, what we know is the best. And I'm just going to arbitrarily change a few things around and see whether we can get a better one. Let's just try. Let's just go non-neo. I don't know. I'm just doing something totally different.
So these are the colours of the routes that
Yeah.
will come out here. Different truck capacities, so a 40 pallet truck, 24 pallet truck, 16 pallet
Yep.
truck.
And this is going to calculate in real time the best use of that fleet and the cost of running it. And it's going to take about 30 seconds, and it's running on a very ordinary Dell desktop computer here. There's nothing flash about that. So one of the advantages are that you can put in all the details of all your constraints, and secondly, they run very, very fast. You get solutions very quickly. And it's iterative as well. So if you do have time, you can run another iteration and get an even better solution.
Pretty ugly.
Ugly because there's a big penalty for not delivering to someone. So I absolutely need to add an extra little truck here before we. What's the smallest truck we got? That guy, I think. So just do one more time. Again,
so
you'll see this area will change. This changed totally down here. And the area will change up the top a little bit to make the best use of those trucks to get that last delivery in.
Yeah, much better. There's a concept in optimization as well, in route planning, called visually appealing routes. You can tell it.
Yeah, makes
compared
sense.
to what was before to this.
Makes sense, yeah.
Yeah.
Great.
Visually appealing, I mean, I'm no expert in this stuff, but does the fact that, say, some of these don't have full circuits, so for example,
Yep.
this blue
Yep.
one
Yep.
is like
Yep.
a straight line, is that an issue? Rather than,
There is potential to say whether
Yeah.
that's where that potential is.
You don't know.
Don't know yet.
Yeah.
But if you look more carefully, these are little trucks, so then perhaps it would make sense to put a bigger truck on.
bigger truck, yeah.
So you've got this little guy. He's probably using up all his capacity just doing
Yeah.
that.
And then
This
he has to
guy's-
sit back,
Yeah. So
So you can replace trucks, large
Yeah.
trucks, yeah.
You could put that in as part of the industry. You could say, look, so the problem is the driver's got to get home.
well, he's got to get home
He's got to
anyway.
get home, so he's, where
Let's do
food is,
circular routes.
he's got to have circular routes, or the driver's not allowed to drive for 24 hours.
Yeah.
So you can place all those constraints back into the system,
Yeah.
and then you can show that as part of the solution.
One of the really annoying constraints for TipTop in delivering into Wagga was that the last 200 metres, because of council regulations to a specific drop and very important drop point, they could only send in a smaller truck.
Right.
So they had to send a small truck all the way from Sydney every day to that drop point because of the last 200 metres. And now, with that kind of information, stark reality, that issue was probably really annoying the local team at TipTop, but hadn't ever bubbled up to the top.
Yeah.
Suddenly, you can have an Andrew Reeves, the CEO of George Weston, talking to the local council
Yeah.
and having a more meaningful conversation, and it can have ramifications across the whole industry.
So I've just put a bigger truck here. I want to make sure I deliver everybody, so I've added a bigger truck here. I'm guessing, and you'll see the routes will be quite different now.
Because they can do longer.
And you'll probably find something will reach it down out of Sydney down into this area.
That's good.
Right, so this Sydney guy is going all the way down here, and that's actually, believe it or not, the most cost-effective solution. But it's still expensive. It's still 11% above what
But
we
if
know is
that
the
was
best
your
answer.
fleet, and that's your an operating constraint,
Yeah.
then that might be the best that you can do.
Exactly.
Got it.
Yeah. So,